Selamat siang.
Is that okay?
Yeah, that's okay.
Okay. All right. So Jati, how are you doing?
Yeah, really great actually.
All right. So good. Okay, I can say that. He's one of the best, also best PhD students. Yeah, he just got his PhD degree this March, right? So I hope you're doing great. Jati and all organizers, and particularly Dr. Afif, and also all organizers, chairs, and all volunteer supporters. Thank you for having. I'm Hirono Wasaki. As Jati introduced me, that I'm currently working at the Waseda Embassy as full professor, but also I'm leading the entire IEEE Computer Society as a president. So it's my great honor to give you a kind of overview of the CBOK guide, software engineering variable knowledge, and also the kind of future direction, particularly AI and software engineering. And I'm currently intensively working on that. And actually, Dr. Jati also, has done great. And I hope that you are continuing doing great, right? So, okay. So then then I show my screen. I hope you see my screen.
Still loading. Maybe wait a moment. Yeah, we can see it now.
Great. Okay, so today my talk is titled CBOK Unbound Redefining Software Engineering for Autonomous Area. So particularly, I will firstly briefly introduce you the latest update of CBOK guide, software engineering body of knowledge, then particularly we need to envision the future evolution of CBOK guide, particularly AI and software engineering. There will be two. I think I hear some voice, so no, some noise. So maybe you may, but okay. Anyway, so then let's move on. So, well, before moving further, as I said, I'm leading the entire IEEE Society as a president. So I want to just briefly introduce you. What is IEEE Society? I hope that most of you are already the member of IEEE Society. Okay. So actually, IEEE Society is going to have a huge milestone next year to celebrate 80th anniversary. So actually, this year is 79, and so next year we are going to celebrate 80th anniversary. So we are very proudly, I'm very proudly say that Computer Society is always the world's largest professional organization dedicated to computing. And you see that we have more than 375,000 community members, and we have more than 1,000 chapters. So I think in Indonesia, of course, there are a couple of chapters, right, such as maybe Telkom University, but also some other universities, and also chapters and regions as well. And under my presidency, particularly this year, I said we have three goals. One is to engage more students, young early career professionals. And I think today perhaps we see many students, but also early career professionals. So welcome to our community, and so let's grow this community together, right? And also to engage more industry. That is also very important because often innovation comes from the kind of intersection between academia and industry, and kind of connection between industry needs and also academia sees, and or even industry own needs and sheets, and so we need to engage more industry. And last but not least, based on that, we need to lead the way in new technical areas. That is today's also another topic, that how we can envision the future. Okay, what's next? Beyond the current, for example, generative AI and also quantum computing, and of course we see that last night, or maybe today, or anyway. So Nobel Prize, goes to the quantum mechanics, right? So like this, Computer Society is actively involved in the quantum computing based on, of course, quantum mechanics. So like that. So we are, and I'm leading entire Computer Society with those goals. Okay, so then one of the important products provided by IEEE Society is a newer IEEE Society technology predictions. So every year, almost every year, by the team led by Dehan. Dehan is a former president of IEEE Society. his team annually envisions or predicts, what's next. Okay, so this is a kind of a excerpt from the kind of mega trend taken from the latest IEEE Complexity Technology predictions. So basically, we need to consider three key areas. One is AI, of course, particularly artificial general intelligence, composed by generative AI, of course, but also next generation AI, metaverse, and also low power AI accelerator. And so, such AI or AGI would be a kind of an engine, or it shall accelerate any digital transformation in almost any domains and verticals, such as healthcare, quantum computing, of course, and also autonomous systems, cybersecurity, and so on and so on. And last but not least, we need to move towards sustainability. Okay, that's a point, because our ICT related activities shall be sustainable, and also we need to contribute to the sustainability of the entire society. Okay, not just computer society, but much wider external community. We need to contribute. Okay, so that's a kind of quick view of the IEEE society, and also the then, well, since as Dr. Chatty introduced me, that I'm basically working in the area of software engineering. So in these years, I'm honored to lead the evolution of Guide to the Software Engineering Body of Knowledge, or in short, SWBOK Guide. Okay, so SWBOK Guide is a kind of guide, of course, and it's a kind of system of knowledge items and areas to guide researchers and also practitioners to identify and have common understanding on generally accepted knowledge in software engineering. And because software engineering is quite broad, right? Software engineering is not just about computer programming, but also software requirements, design, and testing, and also even management and process, and also some organizational aspect. All those things are kind of a part of software engineering. So we need to clearly define what's the boundary of software engineering, what is software engineering, and what is not, but connected. Okay. And also, SWBOK Guide is a solid foundation for certification and also education curriculum. So indeed, currently, Computer Society is reorganizing running courses and also professional certifications. So yes, Computer Society is going to certify software engineering professionals. Well, hopefully soon, within this year, because my presence, term will be ended at the end of this year. So I hope that within this year, we can announce the reorganized certification program aligned with the latest SWBOK Guide. So, SWBOK Guide has quite a long history since 2001. So it has almost 25 years, history. And it has been, of course, adopted as a standard, as ISO standard. Okay, and yes, by together with all distinguished editors and contributors, we have successfully released the latest version 4, last December 2024. So actually, the history of SWBOK Guide can be seen as a kind of rough history of software engineering itself. So and basically often the software engineering endeavors can be seen as a kind of software techniques based on the platforms and computing techniques. Yeah, for example, early 1970s and 80s, at that time the mainframe, so the software engineering was about quite an early endeavor, like structured programming, also waterfall process, and then yes, personal computing, also client servers came. So then there are some other software engineering techniques such as formalization, software design, program generation. Those are kind of early endeavors of software engineering. And then yes, we know that internet came. Okay, so then a lot of software engineering techniques have been invented at that time, and I'm quite lucky because at that time I joined this community, such as object orientation, requirements engineering, modeling, verification, reuse, and the process became much more iterative and also incremental. So and most of these techniques and practices are still useful, right? such as, for example, yes, we are using object orientation. Requirements engineering is much becoming important so far in the era of generative AI, but also software modeling. Yes, we are doing software modeling and verification and so on. And then ubiquitous computing can represented by iPhone. Okay, so it's now everyone is using kind of much more personalized devices. So so that's why software engineering community needs to respond to the massive demands of much more personalized and context oriented software services. Therefore, software engineering community has invented much more advanced software engineering techniques like model driven software engineering, product line, global software engineering, open source, of course, value-based software engineering, and also the kind of and also integration between the systems engineering and the software engineering. And then the process has become much more agile, much more flexible, much more dynamic, and also focusing on not document, but focusing more on executable software. Okay, so then where we are now in, so now we are in the era of IoT and big data and AI. So software engineering is becoming much more empirical software engineering. That's also data driven and also continuous and such as continuous integration and building and testing, and everything can be continuous. Okay. So and yes, software engineering and with other related areas such as IoT and also AI. That is today's main topic later. And so then the process has become much more DevOps, like not just releasing software and that's it. No, but we need to work on together with operation side, right? So that's a kind of a tight communication and collaboration between development side and also operation side. That is a kind of very fundamental aspect in the modern software engineering. Okay, so then CBOK Guide version 4 has somehow encapsulated such not state of the art, okay, but well accepted knowledge in such era towards AI empowered and also AI software engineering. So once again, CBOK Guide is not a latest handbook or something. No, CBOK Guide is not a research paper or but CBOK Guide is a kind of collection and system of knowledge items. Those are well validated, okay, and well accepted. So that's the point. So okay, so this slide shows how the CBOK team led by me evolved from last version 3, published 2014, so 10 years ago, almost 10 years ago, and to the version 4, 2024. So actually, it took 10 years. And the right-hand side shows the version 3, and right-hand side shows the version 4. So version 3 was, of course, well designed, from requirements to design, construction, testing, maintenance, together with some other, maintenance things such as configuration management, engine management, and so on, and also based on some foundations. All right, looks good, but right-hand side, okay, since many software systems are becoming so complicated and complex, such as AI software systems, of course, but also AI systems. IoT systems also, so blockchain-based systems. So almost all software systems are becoming so complicated. Therefore, it's time to emphasize again the importance of architecture. So every software profession needs to address such fundamental software architecture disciplines. To emphasize that, we decided to have architecture knowledge area here. That's one thing. Okay. And another thing is, yes, operations. As I said, now many of projects are based on DevOps. It's not like releasing software and that's it. No, almost endless. Okay, release software, but also use it and customer voices and the result shall be reflected into the development again. So it's a kind of very continuous software engineering. To reflect such modern software engineering and also operation, we decided to have new knowledge area here, operation dedicated to operations. And actually, it should be quite natural, right? Left-hand side, you see that there's no operations knowledge area. So it's something strange, right? Because because software must be used by someone, right? And then provide some values. So it's quite natural to have a knowledge area dedicated to operations, and also software security. Well, of course, software security is actually one of the software quality attributes, as such as software reliability, maintainability, and so on and so on. But software security is quite different from some other attributes. Okay, because software security needs to address such malicious attackers or malicious users, and they would take advantage of take advantage of some vulnerability, and so it's quite different from other quality attributes. Therefore, and indeed, this is an error of IoT or Internet of Everything. Almost any software is connected, right? There's almost no single software isolated from other network and software. So it means that almost every software project need to address software security. To emphasize such aspect, we also decided to have new knowledge area dedicated to software security. So these are all three major newly added knowledge areas: architecture, operations, and security. And also we have added some modern software engineering aspects, such as agile DevOps. Yes, those are kind of somehow incorporated into most of knowledge areas, and also AI and software engineering. Well, actually, since once again, CBOK Guide is not the latest handbook, okay, but CBOK Guide shall encapsulate the well-accepted knowledge, okay. So, what about software engineering and AI? It is exactly emerging right now. So it's right now, it's somehow hard to say what is well-accepted knowledge in AI software engineering and what is not. We decided, we saw it's somehow too early to do so. Therefore, we didn't make new knowledge area dedicated to AI and software engineering, but somehow incorporate that topic under the existing knowledge area. So maybe in the next version of CBOK Guide, perhaps we will extensively address AI and software engineering, maybe having a new knowledge area, or maybe like Agile, AI software engineering could be incorporated into most of the knowledge areas in the next version, maybe 2030 or I don't think 2035 but maybe 2030. Okay. All right, so then I want to just briefly introduce you those three knowledge areas newly added. So here's the topic structure of software architecture knowledge area. It consists of four topic areas, including software architecture fundamentals, architecture description, architecture process, and also architecture evaluation. Well, these are quite, actually this area is quite, well established, and actually software architecture has a quite long history. You might know, maybe more than 50 years history, and yeah, for example, with respect to, for example, stakeholders and concerns, yeah, so we derive the kind of very popular view on that, such as architecture analysis and synthesis and evaluation, and to address different concerns given by multiple different stakeholders. This is a very typical kind of view on the software architecture activities. And not only this, but also architecture views and architecture styles, patterns, architecture description language or ADL, or so you may take a look at this knowledge area to grasp the entire structure of the software architecture area. And a second new knowledge area is software security. Okay, so well. Yeah, software security. We need to once again in the era of IoT and also Internet of Everything. So we need to always address software security. such as software security fundamentals, management organization, security engineering process, engineering for software systems, security tools, and domain-specific software security. I think this is very interesting, right? Because security is quite unique attribute compared with other quality attributes. So it means that often vulnerability and also then and corresponding countermeasure would be strongly specific to the very certain domains and platforms. So engineers need to address such domains, often domain-specific and also platform-specific security concerns. To address such aspect, we decided to have topic area dedicated to domain-specific security, such as security for containers and clouds, security for IoT, and also security for machine learning applications. So maybe in the next version of CBOK Guide, we may have more here, such as security for large language model-based applications or something like that. And yeah, there are also a lot of very core knowledge items in the software security. For example, I'm a kind of pattern guy, okay? So I always address patterns to address to explore new areas such as software security and also machine learning and IoT and so on. And so in software security, yes, we need to consider security patterns because security patterns encapsulates the problems and also a kind of recurrent knowledge, validated knowledge of problems and also corresponding security solutions. And my own research, or according to our group's research, we identified that the most frequently used measure security pattern is RBAC, role-based access control. So the problem is how do we assign rights to people based on their functional task? A corresponding solution is assign users to roles and give rights to these roles rather than assigning roles to each individual, right? And it is truly a quite well adopted pattern into most of software systems. So like this, software security knowledge area encapsulates what software engineering professionals need to know. And so it means that we can also use this for teaching students, right? Because students need to understand such breadth or kind of variety of software security topics. And last but not least, another new knowledge area is software engineering operations, from operations fundamentals, operations planning, operations delivery, operations control, practical considerations, and operation tools. Yes, and once again, tools are very interesting, right? Because many projects are adopting DevOps, such as containers, virtualizations, continuous building, package and deploy, testing, monitoring, and so on and so on. And almost across all topic areas, DevOps has been incorporated. So I recommend you to take a look at this knowledge area to capture the entire view on software, latest modern software engineering operations. Okay, so then what's next? Of course, it's hard to predict the future, but we need to try. Okay, so well. Once again, as I said, every year IEEE Computer Society predicts the future. Okay, so then based on such technology predictions, we can try to predict the future of software engineering. Okay, so in next 5 years or 10 years, we will see that more spike of software engineering plus generative AI. Actually, it is happening right now. And also software engineering plus quantum computing. Yes, it is also, well, it was still quite, quite immature, but it is going to happen, okay? And also software engineering plus sustainability, autonomous computing or autonomous systems, and also software engineering plus computing continue, It means from edge devices to fog and cloud computing. It's a kind of continuous execution and also computing environment. And then the process would be much more AI assisted DevOps, or I could say OpSDev. OpSDev means that because generative AI can generate software, right? So we will operate. We could generate software and operate it first, and then followed by development or customization or refinement or modification of such operated software. So we would say that is not DevOps but OpsDev. So like this, process could be much faster, much more flexible, supported by AI. That could be a kind of very promising direction. And actually, it is happening right now. Actually, okay. All right. So to accelerate such software engineering evolution, and also evolution of CBOK as well. This year we launched a new community-based workshop and summit. That is IEEE CBOK Summit. That is a premier industry-focused event, bringing together practitioners, but also researchers and educators, and also, of course, also students to collaborate and share experiences, challenges in the area of not only CBOK guide, okay, but also any general knowledge and also skills and also competencies, as well as related topics like professional training, also certification, and of course this CBOK Summit, of course, encourage using latest CBOK guide. And this year, I was general chair of this summit, and we held this CBOK Summit co-located with ICSE. ICSE is the top venue in the software engineering, and we have around 50 participants, and it was so very successful, and we got a very positive response from all, not all, but most of attendees. Okay, so we plan to hold the second edition of this CBOK Summit in next April, Rio de Janeiro, Brazil, co-located with again ICSE. So it should be a very great opportunity, right? To explore what's the latest of CBOK guide and also related concepts and what could be next, okay? And so we are currently receiving extended abstract submissions limited to 5 pages each, and its submission due is October 20th. So you still have around, I think, 2 weeks around. So please consider your submission. Just 5 pages, up to 5 pages. Oh, but if you miss this submission opportunity, there is another potential submission opportunity. That is talk summary. Well, although talk summary will not be included in the proceedings, but still there will be that should be also a great opportunity to speak up. Provide your finally okay. Anyway, so that should be also very important opportunity, okay, to share your knowledge and also exchange ideas. So please submit your extended abstracts or talk summaries and join this community and grow this community together. And let's so see you in Rio de Janeiro next April. Okay, so this is the first part, but then I could move on if maybe Jatiya, then followed by technical top discussions, but I may take some questions, but
Okay.
yeah.
So maybe we can take some question first, maybe just one or two.
Then I will move on to the technical topics.
Okay, let's start with the Swebok part. Anyone has a question? Oh, right, there's one over there. Please give him the mic.
Assalamualaikum warahmatullahi wabarakatuh. My name is Adam from Bachelor of Software Engineering program. I have a question regarding the future of Swebok. Before that, my research is focusing in mining software theory for SA for AI. So I want to ask a question. So about how can the principle of managed software repository can be applied to the evolution of Swab itself? Could we mine the academic literature, industry reports, or even open source project data to identify the trend and automatically suggest the updates to the body of knowledge? Thank you.
Yeah, I think there will be a lot of variety of opportunities, right? And as you said that open source reports is one thing, of course, and then and but actually be careful because most of perhaps almost all large language models have been already well trained by the open source repositories, right? Such as GitHub and also Stack Overflow and so on and so on. And actually, most of the large models have been already well trained by open source repositories. Therefore, we need to consider what could be added on to the existing general knowledge already encapsulated in the large language model. So perhaps much more for example, very much more platform specific or much more project specific knowledge, or what we can train for the targeting the large language models. Maybe that could be an interesting aspect. And another thing is, of course, some industry, for example, repositories or even what about universities? Okay, universities should have a kind of some repository of, for example, students made exam answers or student-based project results, or those could be also a kind of potential repository to run something and train large language model. And I would say that it's time to consider not only large language model but also small language model. Okay, because training large language model it's quite time consuming and also not sustainable, and it consumes a lot of energy. So we would expect that for each specific task or for each specific environment or even project, we would consider dedicated small language model rather than large language model. For example, this small language model is dedicated to, for example, teaching, for example, software testing, or this small language model is dedicated to, for example, industrial, coding or something like that. So we could consider such, not only general large language model, but also software engineers and very context and environment specific small language models. So I don't know if this is the answer to your question, but we can consider such repositories and also large language models and small language models and address not only industry but also open source and also even academic context. Okay, so that we can consider.
Okay, thank you very much.
All right. So actually, we have a question on the Zoom chat, but I believe it fits more on the technical discussion after this. So yeah, you
Okay.
can go ahead with your presentation first, and we'll move to the question.
All right. Okay. So maybe I will have more maybe around 20 minutes or so, or maybe 30 minutes,
Yeah.
or
Yeah, around 20 minutes.
okay. All right. All right. So then differently, then this is somehow related to the question. Okay. Thank you for that very interesting question. So now we need to consider the future. Okay. So that could be AI and software engineering. Needless to say that, in particular, we can consider two different but mutually connected directions. That is AI for software engineering, and also software engineering for AI. Because AI is software, right? So we need to address software engineering for AI to ensure good AI for software engineering. So those both in two directions are mutually connected. So here's a kind of a view of the AI for software engineering, from AI assistant to AI human co-value creation. So we can say that software engineering 1.0 is a kind of just using AI as a tool, right? So we have automated many very simple tasks, right? Such as code completion or requirements completion or design correction or something like that. It's a kind of an AI as a tool, right? That's a kind of software engineering very early phase of software engineering. But now we are kind of moving towards software engine 2.0. That is, many software engine tasks have been supported by AI as a partner, okay? And so AI can do some exploration, not only just completion. For example, AI could suggest, hey, what about this idea or that idea? Or even AI could suggest and do reasoning. So as a partner. And that result going to be embedded into product, not only process. And then finally, we are moving further. AI as agent. So such vision could be seen as software engineering 3.0, according to Ahmed Hassan in Queen's University and also some other researchers envisioning quite similar figure. Okay, so in such era, there might be no boundary between or among software developers and users, customers, and agents. All those stakeholders, including AI agents, are software makers. Developers will make software, and users as well, and AI agents as well. So everyone, including AI agent, will be software makers, not software developers. That is our latest vision called Software Engine 3.0, provided envisioned by Ahmed Hassan at Queen's University. But I totally agree about such future direction. And so because AI is going to be more and more autonomous and also support collaboration. And to accelerate such direction in a country, we have extensively addressed many research projects such as prompt engineering and also also security aspect with large language model and so on. So then, what's the latest status of AI for software engineering? So this is a very famous. These are charts taken from the latest literature review on large language models for software engineering, and so according to such literature review, actually most of large language model adoption for software engineering tasks are about software development. It means coding, actually, and software maintenance. Well, software maintenance means actually bug fixing and also refactoring, and so almost 90% is 90% is well too much to say, but yeah, almost 85% is about coding and bug fixing and refactoring as well. So, but in other words, there's much more room for other software engineering activities such as software testing, software requirements, design, and so on. So then talking about software requirements engineering, and actually we are currently working on that. And so we have the kind of intensive survey literature review in the area of large language model adoption in requirements engineering. So this chart shows how the papers addressing the specific requirements engineering phase by using large language model. And actually from requirements engineering, requirements elicitation to analysis specification are kind of very broad scope, but management there are quite few approaches. So it seems still management is quite challenging by adopting large language model. And this matrix shows that how the papers addressing the unique nature of large language models, such as interpretability, reproducibility, controllability, hallucination, of course, and also computational and also economic cost and ethics and security and bias, real-time processing. Yeah, of course, it's hard to do so by using a large language model, and also copyright issues. Those are major issues that we need to address. Not only requirements engineering, but almost any software engineering task when we adopt large language model. All right, so then here's one example currently we are working on in the area of requirements engineering with supported by large language model. So there is a kind of explorative planning and requirements elicitation empowered by generative AI, particularly large language model. So we are currently doing a joint research with a company who has a huge amount of inquiry interaction logs between, for example, operators and customers or end users that are kind of, hey, I have a problem. I can log in, and then operators would answer that, oh, okay, can you try this and that, or a kind of a very interactions, right? And then we can, by using large language models, then we can make a kind of explicit knowledge graph like this by merging similar things, but also align with kind of a terminology like situation, questions, and answers. And based on such explicit knowledge graph, we can construct the personas. Those are kind of user typical profiles. Okay, for example, here for example, novice agency staff and having some specific needs and pain points, and the same is true for some other user profiles or persona, like much more experienced agency staff. So each different user profile persona would have different knowledge, different needs, and different pain points. And based on that, then we can consider further software requirements, elicitation, refinement, and also customization. Okay, so then, again, software large language model adoption is not just about requirements engineering, but also coding, of course, and bug fixing. So that kind of promising direction could be end-to-end bug fixing, from defects detection and reporting and validation, prioritization, and fixing. All those processes shall be end to end. And actually, that is a kind of dream. And still, it's not yet established in practical way. But we need to work on that. So currently, this is just a demo. How fastly engineers can report something. Okay, then large language model would assist extending such a bug report and try to locate the which parts are suspicious about bugs and then fix it. Okay, so okay, this is still a challenge. Okay. Okay, so then and actually the fundamental challenge is actually trust. How human engineers can trust AI. Okay, because as I said, large language model can support many software engineering tasks, not only requirements engineering, but also coding and also even bug fixing, as I said. But the question is, human engineers, do we trust AI? That's a fundamental question. And the answer is actually right now not so. So here's a very interesting latest investigation provided by the team of Ahmed Hassan. So his team investigated a massive amount of pull requests. It means change proposals by AI agents, and how those AI generated pull requests have been approved or not, compared with human generated pull requests. So it means how open source communities trust AI agent generated change proposals. So time's limited. I did not say detail, but okay. So each chart, later chart, indicates the different large language model, but the blue lines shows human generated pull requests. Okay, so you see that agents are really good, of course, in speed for of course generating pull requests or change proposals, but their pull requests approval rate is so low compared with human generated pull requests. However, some documentation tasks surpass human capabilities. Yeah, for example, you can see, for example, here you may see my cursor, right? So this is a comparison between human versus OpenAI Codex. So for the documentation task, AI agent is better than human. So it implies that now this is now the error that no longer that humans will make documents, but AI agents can do that because AI agent is better than human, and actually we trust that. Okay. On the other hand, some other tasks, like for example, building and also feature implementation or bug fixing, you can see a significant gap between human and AI agent. So this is actually the latest actual situation. Actually, human engineers and open source community are often not so trusting AI agent generated pull requests or change proposals. So we have to move on, right? So we need to improve more, the capability of AI agents, and we need to research more about how we can establish such trust between human engineers and also AI agents. That is a huge important research direction. So, as I said, right now, human engineers are not so trusting AI agents, but AI agents can do some right now. Yeah, and actually there's a lot of approaches to adopt large language model agents to create software products, almost end to end, or fully automated software development. And that is a kind of also very ambitious direction, right? And such as MetaGPT or ChatDev, and but still these are kind of not industry adopted approaches. But there are some, of course, as I said, there are some tasks have been already very automated or supported by AI agents. So to increase more trust, or in other words, how we can move towards responsible AI agents, we need to improve more trust through controllability, explainability, and also transparency. And also, so then we have to examine more about bias and also data quality and also computational costs, and so, okay, so these are kind of fundamental challenges. Okay, so maybe in next, if I can have, then I may wrap up just maybe 5 minutes. There's also software engineering for AI. Okay.
Okay, go ahead. 5 minutes.
5 minutes. Okay. All right. So then, what about the other direction? Actually, to increase such trust, we have to work on more intensively on software engineering for AI, and there are a lot of approaches about the software engineering for AI. So this is a very famous. It's quite old, 3 years old, 3 years ago, but still useful. They investigated around 250 papers aligned with CBOK guide knowledge areas, and you can see that most of research works are about software testing. Okay, but it seems that we can do more about software requirements, software design, and also software process for AI software systems. Yeah, for example, I'm working on in the area of machine learning design patterns. There is about how we can have better design of machine learning based application. So I will skip details, but yeah, for example, here's a pattern, so-called two-stage predictions. Here's a problem, solution, and so kind of combination of multiple different machine learning models into the same a single software system. So like this, we can document more good design and good architecture of machine learning and also AI-based software systems. And indeed, and I'm working on just that area. And for example, 3 years ago, we published a paper titled "Software Design Patterns for Machine Learning Applications," and unfortunately, it got a best paper award. And we documented many patterns like encapsulation of machine learning models within rule-based safeguards. Yes, indeed, particularly for targeting safety critical systems, we need to combine both machine learning models together with rule-based deterministic safeguards, right, for safety critical systems. And also we need to ensure explainability by having proxy model. So like this, there are a lot of common good design and architecture to address machine learning and also large language model nature. All right, so then what about testing and so debugging? Yes, as I said, many researchers are working on machine learning based software testing. Okay. Yeah. And one of the major approaches is metamorphic testing. Okay. So metamorphic testing is the testing about the when we can predict what could be changed in the output when we change input. For example, if we add noise, then what we expect in output is there's no change, right? So that is also the kind of very typical metamorphic testing. Or if we input similar inputs, then we would expect similar, but slightly different output. So like this, if you can predict some change in output by changing the input, then that is a metamorphic testing. And that is adopted in many areas, not only on automated software, but also even large language model applications, because you can change the input, and then you can monitor how the output will be changed or unchanged. And once you identify some bugs or defects or low performance in machine learning or even large language model, then you need to do some repair. So repair is about aggressively modify some parameters. For example, in some neurons or some parameters. And this area is quite extensively researched by many researchers, such as deep-fold and also distributed repair, and there's a lot state of that in the area. And finally, yes, and actually Jati, has read the project about composing all those things together, right? Such as requirements engineering, modeling, and also patterns, and also repair, and into the modeling-based framework. All right, so I think that's it, and yes, so today I'm really happy to introduce you the CBOK latest update. But also I somehow introduce you the promised directions of both, AI for software engineering and just somehow software engineering for AI. So thank you for listening.
Okay. Can we have a big applause first for Professor Roshizaki? So yeah, we have a lot of interesting topics today. So we have 3 actually. 3 topics at the same time. So I will not open the question and answer session first because we already have the question on the text. Can you show it on for the on-site session? So yeah, first basically I will not read everything about it, but he works in testing and automation, which also use AI. So the 3 question is, first, I guess you can answer it shortly, right? To save some time. In your view, how should we balance the push for full autonomy with the need for human oversight? So it's again balancing. And second, with ML or LLMs in automation pipeline, how can we ensure reliability, trustworthiness, given their non-deterministic nature? Okay, that's one good point. And the last one is, do you think the growing reliance on LLMs will redefine trust? Okay, we have the key terms trust in software engineering. Not only correctness, but also transparency, accountability, and safety. Okay, so maybe you can answer those questions.
Wow, those are really great questions. Particularly first one, I like that. And actually, there is no single correct answer for that. And well, I would say that the risk and how we predict the risk, okay, and also the because and so far sometimes the machine learning-based applications hard to predict what's the risk and how it affects to some values to the, for example, customers or so we need to examine more about risk, okay, and then if customers or the society could take some risks, okay, then perhaps we can automate more. But in other words, if we predict much higher risk, okay, then perhaps always somehow human in the loop. Although we can automate most of tasks and processes, and also in the area of large language models based applications, requirements engineering and validation by testing would become much more important. So I can say that. And in other words, other tasks could be mostly automated, That could be one potential direction. Okay, that could be the answer to question one.
Okay. Do you want to answer the rest of the question?
So, um,
So basically, yeah, it's
yeah. Well,
reliability.
yeah. Second question is also somewhat related, right? And yeah, I think but well, um, I think the in perhaps the rational, and if we automate something, by large language model and generative AI, that's fine. But sometimes we have to examine what's the rationale of that. Okay, so we need to have evidence for each design and design rational, I think. So perhaps so that's why large language model based software engineering task should be much more explainable. Okay, what's this design rationale for each task? That could be much more important. And then and particularly by considering such non-deterministic nature. Okay, I think it's design rational and what's the reason of such each design decision? That could be where logged or recorded, and then if something happens, then human engineers should examine such log or design rational records. Well, again, that is. And also, as I said, often for particularly some safety critical systems, we need to combine such non-deterministic nature machine learning parts together with deterministic part. So that's why I documented a pattern, very famous pattern. There is safeguard, rule-based safeguard. Okay, we need to encapsulate machine learning model within the deterministic rule-based safeguards. And the last question.
I think it's also related.
Yeah, exactly. Well, exactly. I think question 3 has already answered it by itself. Right? Exactly. Trust is not just about reliability or in some narrow sense, but how we can ensure transparency and also accountability and also explainability and safety as well. And so we need to address such multiple aspects, not just a very narrow sense of trust like reliability. And no, we need to address such multiple aspects. So yes, and perhaps finally we have to ensure. So what is the value? Okay, and actually there's no single correct answer. What is value, right? Sometimes value is just money, but not just money, right? Just not only financial value, but also societal value and values. So many having different aspects. Okay, I think this is not a single answer, but yes. So we need to work on that. So thank you for your questions.
Thank you for the great questions. Thank you for the great explanation and answers. Actually, if we have unlimited time, which is our dream as a software engineer, because our enemy is time always, because we always chase the deadlines. So yeah, we cannot have more question because I believe everyone here already prepared for lunch. Maybe in Japan it's already 2 p.m., but it's lunchtime over here. So yeah, thank you very much, Professor Washizaki. So you started with selamat siang. I'll tell you one more saying in Indonesia, which is terima kasih.
Yeah, terima kasih, of course. Thank you. And also, I would say sampai bertemu lagi.
Sampai jumpa lagi. Okay. Okay. With that, I will conclude with one takeaway. Swaybook is ever evolving, so hopefully you in the future will be the one that evolves it, not only just following it. Okay, with that, I need to miss you again.
All right, so ladies and gentlemen, let's give a warm applause for this session. I would like to invite Professor Hironori Washizaki and also Dr. Inch Jati Hiliamsyah Hussein to kindly be on the camera. Would like to deliver a token of appreciation or certificate of appreciation from the Committee of ICOSATE 2025. So for the first certificate of appreciation will be delivered to our speaker. Thank you, Professor Hironori Washizaki, for this amazing, insightful session. And also, the next certificate of appreciation will be delivered to our moderator, Dr. Inch Jati Hiliamsyah Hussein, for this interactive session during leading the session, of course. All right, so ladies and gentlemen, once again, let's give a warm applause for this amazing session. We believe you have gained a lot of insightful knowledge, and of course, we hope that it can be implemented later on in your research or probably in your academic situation.